Hello and welcome to the first installment for our ecosystem unit here at NICC Environmental Science here at Calmer. Again, please check the course syllabus to see the chapter readings for each unit and each week, of course. The ecosystem unit, the first set of readings for this come from chapter 3 and 4, excuse me, in the Miller-Spoolman textbook that we're using, and it's really laying out what ecosystems are, how they work, and then moving into the question of biodiversity in chapter 4, and chapter 4 really starts talking about how, in what ways organisms interact with their environments. The first part of chapter 3 is really talking about the basic life support systems on Earth and understanding how these big global systems are interacting or functioning at any rate, and that are really there to drive the ecology or the life cycles of organisms within these groups. When we look at these four main components, we have the hydrosphere, the atmosphere, the geosphere, and the biosphere. And all of these parts of the planet are interacting. The hydrosphere is the sort of aquatic or water component of the planet. The atmosphere is the air around us. The geosphere is the sort of the physical structure, the earth, the rocks, things like that. And then the biosphere is the living component that may be in any one of those other three components. And then those interactions are really what we're talking about when we're talking about ecosystem functioning. Within each of these different sort of areas of these life support systems for the Earth, they're all really being driven by primarily this one source, which is the sun. There are certainly some life forms that exist in deep sea vents and habitats like that that never see sunlight and never have interaction with light energy that are chemosynthetic. But for the vast majority of life on Earth, and for most of what we're going to be talking about in this class, it's fair to say that the sun is the energy driver for this planet. And without the sun to drive energy into our planet for the utilization of other organisms and some of these cycles, in fact, are driven by the sun, life as we know it would cease to exist on this planet. We also have this fantastic feature of our atmosphere that produces this greenhouse effect, which provides this sort of warm, snuggly blanket for the Earth to maintain a generally comfortable temperature for life to exist. Now, to be sure, there are extremes of temperature, both hot and cold, but for the most part, most places on this planet are conducive for planets to live. Not planets to live, on this planet are conducive for life to live. When we're talking about the functioning of ecosystems, we can also think about the movement of energy through those ecosystems, and energy in these biotic ecosystems, energy in these systems is really being contained into life via these groups of organisms that we call producers. And these are photosynthetic organisms. They're green things, not frogs, of course, but plants and algae, things that are photosynthesizing, that are able to capture sunlight energy and convert it using water and carbon dioxide into sugars. Now, those organisms as producers are harnessing that sunlight energy and making it available to other organisms. As humans, we cannot stand outside and sit in the sun and say, I'm full, I ate my lunch. We rely on other organisms to do that, but when we're eating plants, for example, that energy is just converted sunlight energy. And that when we're moving through these different energy levels or feeding levels, they're known as trophic levels. And this movement of energy through these different trophic levels is an important part of understanding how ecosystems function. So we're starting out with these producers. Organisms that eat those producers are known as primary consumers. Oftentimes herbivores are put into this sort of primary consumer role. If you think about cows or sheep, or even small fish that don't eat other that don't eat other fish, that just eat green algae, those would be primary consumers. Secondary consumers are organisms that eat the primary consumers. Now, sometimes you have organisms that are omnivores that eat many things, like humans, for example, are omnivores. We eat plant material, animal material. We're pretty happy to eat whatever. They can fall into that primary, secondary consumer role pretty easy. We can also move up to a sort of a different level and say we can have secondary or tertiary consumers that are eating the things that eat the things that eat the things that eat the things that eat the plants. I think I got enough eating the things in there, but you understand that as we have at this base the plants, and then primary consumers are eating those, secondary consumers are eating the things that are eating the plants, and tertiary consumers are eating those consumers as well. But we can move through these different trophic levels and understand who's eating who and then how energy is moving through these systems. In the end, though, all things, biologically speaking, get broken down and are eventually consumed by decomposers and detritus feeders that really work at breaking down organic matter, whether it be feces or decaying carcasses, whatever. Those then recycle those nutrients back into the system for plants and other primary producers to utilize, and the cycle begins again. So these energy cycles and nutrient cycles move in this way in these ecosystems and work at functioning in this way. One of the places where a lot of this decomposition occurs is in the soil, and soils are important components of ecosystems. They house a lot of organic material that's being decayed and inorganic material that's being broken down, and we really have, and oftentimes a lot of water is associated with the soil, and so we have this interaction of these living and non-living components in these soil matrices. And so soils are important things to think about. They're more than just dirt. They're oftentimes have very large numbers of living organisms in and around them, and they really form the foundation to these energy systems, because without well-developed soils you can't have well-developed plant communities and or as well-developed plant communities, and you end up with these different more poorly functioning systems than you might have if you did have good soils. When we have energy moving through these systems, again, we have this energy starting from the sun and moving through these trophic levels, first and foremost in these producers, and then the primary consumers and on through. But really, again, this is moving energy through these systems, and energy movement through these systems happens to be really, really inefficient. If you look at figure 3.11 in the textbook, it has these bars and this bar graph where you have these large this large base at the bottom is the energy sort of collected from the sun by these producers. But as we move up these different levels, you get this very steep sort of pyramid shape where you have this very skinny little bit of energy at the very top where you have these tertiary consumers. That's because much of the energy that we consume is lost as heat. And whether you're a cow or a primary consumer of some sort, most of what we consume is simply burned off as heat and lost into the atmosphere. And so we lose a lot of the energy that we consume. Obviously, we don't store all of the energy that we use or that we consume. We'd be enormous if we were the sum of all the energy that we consume. Most of it is lost into the environment. And so this very inefficient system, but it doesn't really matter that this system is really inefficient, because fortunately we have this essentially inexhaustible source of energy, the sun, driving these energy systems. And it's been billions of years that we can count on the sun rising. And just because the sun sets today doesn't mean that it's not going to rise tomorrow. I may eat those words, but I'm going to stand by those words on the internet that the sun's going to rise tomorrow. And so, the biology on this planet can count on the energy from the sun sort of reintegrating into the biological systems to keep them driving forward. Along with energy cycling through these systems, we also have the cycling of nutrients and other inorganic components. So we have the water cycle. The sun is also driving the water cycle. Most of the water on this planet is housed in the oceans, and as the sun beats down on the oceans, it heats it up, evaporates it, and sends it up into the atmosphere, where it moves across land masses and falls as fresh water and moves through the rivers down back into the ocean. That's a cycle. Again, the book does a really good job of giving good illustrations of these sorts of cycles. Figure 3.15 is the water cycle. But other things within these systems cycle as well. Nutrients, for example. We can have nitrogen that cycles. And the cycling of nitrogen is really sort of the cycling of sort of things of life. You know, animal material, feces, the physical body structures of animals, things like that. Humans also put a lot of nitrogen into cycles via agriculture and lawn application of fertilizers and things like that. But all of these things move in this cyclical fashion through these different parts of the system. And under natural systems, these or systems that have a low impact from humanity, these cycles work very predictably and very consistently to utilize all of these parts of their components. Once we start putting humans into these cycles, then we get imbalances in these cycles. For example, nitrogen, carbon, phosphorus. These are all cycles that humans have a large impact on because we're simply able to change our environments to such a high degree. That's a brief synopsis of Chapter 3. I think I'll just post a second video for Chapter 4 just to make sure that we're getting enough time on each one, and we're splitting it up a little bit for you guys. I'll finish up Chapter 4 here in just a minute, but thanks for listening. That was Chapter 3.